It is against code to add a breaker box directly off a 100 amp disconnect panel. According to the National Electrical Code, (ONEC), a subpanel must be connected to a main service panel and not directly to a disconnect switch. This is for safety reasons. Overcurrent protection is essential. The main service panel contains the main circuit breaker or fuse, which protects the entire electrical system from overloads and short circuits. If a subpanel were connected directly to the disconnect switch, it would bypass this main overcurrent protection. Isolation is also crucial. The disconnect switch is used to isolate the entire electrical system from the power source for maintenance or emergencies. By connecting a subpanel directly to the disconnect switch, the subpanel would not be isolated if the disconnect switch were opened. The correct way to install a subpanel for the hot tub and pool is firstly, run a dedicated circuit from the service panel in the garage to the patio, and secondly, install a subpanel at the patio with two 20 amp breakers for the hot tub and pool. This method ensures that the hot tub and pool are properly protected from overloads and short circuits, and that they can be isolated from the main electrical system when necessary. For a clearer understanding, let's delve deeper into the specific reasons why connecting a subpanel directly to a disconnect switch is a code violation and poses significant safety risks. We'll explore the fundamental principles of electrical distribution and protection, and how the NEC guidelines ensure a safe and reliable electrical system. The primary reason for the NEC requirement is to maintain proper overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of electricity when the current exceeds a safe level. This prevents overheating of conductors, insulation damage, and potential fire hazards. In a typical electrical system, the main service panel acts as the central distribution point, receiving power from the utility company and distributing it to various branch circuits throughout the house. The main breaker in the service panel provides overcurrent protection for the entire electrical system. Subpanels are used to extend the distribution of power to remote locations or to provide separate circuits for specific appliances or equipment. When a subpanel is properly connected to the main service panel, it receives its power through a circuit breaker in the main panel. This circuit breaker provides overcurrent protection for the subpanel and all the circuits it feeds. However, if a subpanel is connected directly to a disconnect switch, it bypasses the overcurrent protection of the main service panel. In this scenario, if a fault or short circuit occurs in the subpanel or one of its branch circuits, there is no upstream overcurrent device to interrupt the flow of electricity. This can lead to a dangerous situation where the conductors overheat and potentially cause a fire. The disconnect switch is primarily designed to isolate the electrical system from the power source for maintenance or emergency purposes. It is not intended to provide overcurrent protection. Connecting a subpanel directly to the disconnect switch would compromise the isolation function of the switch. If the disconnect switch is opened to de-energize the electrical system, the subpanel would still remain energized, posing a potential shock hazard to anyone working on the electrical system. Furthermore, connecting a subpanel directly to a disconnect switch can create confusion and make it difficult to troubleshoot electrical problems. It can also violate the NEC requirements for proper grounding and bonding, which are essential for electrical safety. The NEC specifies the methods for grounding and bonding electrical systems to minimize the risk of electric shock and to provide a path for fault current to flow back to the source, allowing the overcurrent device to trip. Now let's examine the correct method for installing a subpanel for the hot tub and pool, as outlined in the answer. The first step is to run a dedicated circuit from the service panel in the garage to the patio. This involves installing a new circuit breaker in the main service panel and running a suitable cable, such as UF cable, to the location where the subpanel will be installed. The size of the circuit breaker and the cable must be appropriate for the load requirements of the hot tub and pool. For a 20 amp circuit, a minimum of 12 American wire gauge copper wire is typically required. The cable must be installed in accordance with the NEC requirements for wiring methods, including proper support, protection from physical damage, and appropriate grounding. The second step is to install a subpanel at the patio with two 20 amp breakers for a hot tub and pool. The subpanel should be sized appropriately for the number of circuits it will serve and should have a sufficient ampacity rating. The subpanel must be properly grounded and bonded in accordance with the NEC requirements. This typically involves connecting a grounding electrode conductor from the subpanel to a grounding electrode, such as a ground rod or the metal water pipe. The neutral conductor in the subpanel must be isolated from the subpanel enclosure and connected to a separate neutral busbar. The equipment grounding conductors from the branch circuits must be connected to a separate grounding busbar in the subpanel. By following these steps, the hot tub and pool will be properly protected from overloads and short circuits, and they can be isolated from the main electrical system when necessary. This ensures a safe and reliable electrical installation that complies with the NEC requirement. In addition to the general requirements for subpanel installations, there are specific NEC requirements for hot tubs and pools. These requirements are designed to minimize the risk of electric shock and drowning. Some of the key NEC requirements for hot tubs and pools include ground fault circuit interrupter, or GFCI, protection, bonding of metal parts, and clearance requirements from overhead power lines. GFCI protection is required for all electrical circuits serving a hot tub or pool. A GFCI is a device that detects small amounts of current leakage to ground and interrupts the circuit, preventing electric shock. All metal parts within 5 feet of the hot tub or pool must be bonded together to create an equipotential plane. This helps to minimize the voltage difference between different metal parts and reduce the risk of electric shock. The NEC also specifies minimum clearance requirements from overhead power lines to hot tubs and pools. These clearance requirements are designed to prevent contact with energized power lines, which can be fatal. It is essential to consult the NEC and local electrical codes for specific requirements related to hot tubs and pools in order to ensure a safe and compliant installation. Remember that electrical work can be dangerous, and it is always best to hire a qualified electrician to perform any electrical installations or repairs. A qualified electrician has the knowledge, skills, and experience to perform the work safely and in accordance with the NEC and local electrical codes. Attempting to perform electrical work without the proper training and experience can be hazardous and can lead to serious injury or even death. Furthermore, improper electrical installations can create fire hazards and other safety risks. To summarize, connecting a subpole directly to a disconnect switch is a code violation and poses significant safety risks. The NEC requires a subpole to be connected to the main service panel to ensure proper overcurrent protection and isolation. The correct method for installing a subpanel for hot tub and pool is to run a dedicated circuit from the service panel to the patio and install a subpanel at the patio with appropriate circuit breakers. Always consult the NEC and local electrical codes for specific requirements and hire a qualified electrician to perform electrical work. For further clarification, let's break down the specific sections of the NEC that address subpanel installations and overcurrent protection. While the NEC is a comprehensive document, understanding the key sections will help illustrate why the described installation is a code violation. Article 230 of the NEC covers services, which includes the service entrance equipment and the connection to the utility. This article outlines the requirements for overcurrent protection at the service entrance. Section 230.70a generally requires the service disconnecting means to be located at a readily accessible location either outside of a building or structure or inside nearest the point of entrance of the service conductors. Article 240 of the NEC focuses on overcurrent protection. This article details the requirements for circuit breakers and fuses, including their ampacity, interrupting rating, and location. Section 240.21 addresses the location of overcurrent protection devices in branch circuits and feeders. This section generally requires overcurrent protection at the point where the conductor receives its supply. Article 408 of the NEC covers switchboards, switchgear, and panel boards. This article defines the requirements for the construction, installation, and wiring of panel boards, including subpanels. Section 408.36 requires that each panel board be protected by an overcurrent device with a rating not higher than that of the panel board. Article 680 of the NEC specifically addresses swimming pools, fountains, and similar installations. This article provides detailed requirements for bonding, grounding, GFCI protection, and wiring methods for these types of installations. While the specific sections may vary depending on the edition of the NEC, the underlying principles remain the same. The NEC is designed to ensure the safety of electrical installations by providing a comprehensive set of rules and guidelines. Bypassing these rules can create dangerous situations and increase the risk of electrical shock, fire, and other hazards. It's important to remember that the NEC is not a design manual, but rather a set of minimum safety standards. It is always best to exceed these standards whenever possible to ensure a safe and reliable electrical system. When installing a subpanel, it's also crucial to consider the voltage drop in the conductors. Voltage drop is the decrease in voltage that occurs as electricity flows through a conductor. Excessive voltage drop can cause appliances and equipment to operate inefficiently or even fail. The NEC recommends limiting the voltage drop in branch circuits to 3% and the total voltage drop in feeders and branch circuits to 5%. To minimize voltage drop, it's important to use conductors of the appropriate size and to keep the length of the conductors as short as possible. Online voltage drop calculators can help determine the appropriate conductor size for a given load and distance. In addition to the NEC, local electrical codes may also have specific requirements for electrical installations. It's important to consult with the local authorities to ensure that all installations comply with these codes. The local electrical inspector can provide valuable guidance and ensure that the installation is safe and compliant. Remember, electrical safety is paramount. Always prioritize safety when working with electricity and never attempt to perform electrical work without the proper training and experience. Now, let's consider some additional scenarios and potential issues that could arise from improperly installing a subpanel. One common mistake is failing to properly size the conductors for the load. If the conductors are too small, they can overheat and potentially cause a fire. The NEC provides tables that specify the ampacity of different types of conductors based on their size and insulation type. It's important to consult these tables and select conductors that are appropriately sized for the load. Another potential issue is improper grounding and bonding. As mentioned earlier, grounding and bonding are essential for electrical safety. Improper grounding and bonding can increase the risk of electric shock and create a path for fault current to flow through unintended paths. The NEC provides detailed requirements for grounding and bonding electrical systems, and it's important to follow these requirements carefully. Another common mistake is failing to properly protect the conductors from physical damage. Conductors should be installed in conduit or other protective raceways to prevent damage from abrasion, impact, or other hazards. The NEC specifies the types of raceways that are permitted for different applications. It's also important to ensure that all electrical connections are properly made and tightened. Loose connections can create heat and potentially cause a fire. All electrical connections should be made with approved connectors and tightened to the manufacturer's specifications. Regular maintenance is also important for ensuring the safety and reliability of electrical systems. Electrical systems should be inspected periodically for signs of wear, damage, or corrosion. Any problems should be corrected promptly by a qualified electrician. It's also important to keep electrical panels and equipment clean and free from dust and debris. Dust and debris can accumulate and create a fire hazard. In summary, properly installing a subpanel requires careful attention to detail and a thorough understanding of the NEC and local electrical codes. It's always best to hire a qualified electrician to perform this type of work to ensure that it is done safely and correctly. Bypassing the NEC requirements can create dangerous situations and increase the risk of electrical shock, fire, and other hazards. Remember, electrical safety is paramount, and it's always worth the investment to ensure that electrical installations are done properly.